Hi, everybody. My name is Pam Habersetzer. I'm the secondary math TOSA at the district office. And today I'm going to be sharing with you a lesson from Algebra 2. This lesson comes from our illustrative math curriculum. It's the second lesson in Unit 1. The unit is about sequences, and this particular lesson introduces students to geometric sequences. So the opening structure of this lesson, students are going to take a look at an article from the Columbian. This article talks about how fast the population of Washington State has grown in the last year. And in particular, it names Vancouver as the second fastest growing city in our state. And that we've added 4,400 people to the city of Vancouver in the last year. So the first thing that I will have students do is take a few minutes to read the first part of the article and talk about the fact that our city is growing quickly. Then I will set them to work in small groups of 2 or 3 students to brainstorm about what the possible problems that such rapid population growth might cause. I would give them some time to think individually first, and then time to share out with their groups. Hopefully, they're going to come up with a variety of different problems that might range from problems for the whole city to problems for their family to individual problems for they themselves. Examples might be lack of affordable housing. Maybe they can't get a dinner reservation at their favorite restaurant. There will be more traffic. There might be less space to recreate in parks. It might be harder to find a space where that's not crowded. There might be a water shortage. You may not be able to water your lawn and keep your grass green. There also might be implications more personally at school. The halls might be crowded. Class sizes might be bigger. It might be harder to get help from a teacher. So those are just some examples of things that kids might come up with. After brainstorming, we'll have a quick discussion about how complex sometimes these problems are for people to solve, and that one of the things that we often do in mathematics is we take complex problems and come up with simpler models to help us make sense out of what's happening. So the next thing that we're going to do is we're going to represent a piece of paper, or the city of Vancouver, the space that's available as a piece of paper. So each group of students is going to be given an 8 by 10 piece of paper that represents the limited amount of space that's available in the city of Vancouver. Next, they're going to take that piece of paper and they're going to do a series of cuts. So they'll cut it in half. They'll record the number of pieces and the area of each piece. They'll then stack those pieces on top of each other, cut them in half again, and again, record how many pieces and the area of each piece. Hopefully this will help them to see that as you have more people in your city, you have to divide the space into smaller and smaller pieces to accommodate more people. So this is a visual representation of how a city or any space might become more crowded over time. Hopefully, as kids fill in the table, they're going to see some patterns about what's happening in both the number of pieces and in the area of each piece. They're also going to be asked to graph those relationships. They'll graph the number of pieces as a function of the number of cuts and the area of each piece as a function of the number of cuts. And again, hopefully they'll make some connections between the patterns that they see in the table and the patterns that they see on the graph. Then there'll be some discussion questions that they can consider in their groups. Specifically, I would want them to focus on the strategies that they use to find patterns, focusing on, if I didn't immediately see the pattern, how might I use the numbers in the sequence to actually find the pattern, and how could I describe that process to someone else? And how then can I use that pattern to generate more terms in that sequence? We would also, in that class discussion, actually name the sequences as geometric and define those as multiplicative patterns, also pointing out to students that in the area pattern, Many students will name that as a division pattern, and then talking to students about how it can be also thought of as a multiplicative pattern, and understanding that dividing by 2 is the same as multiplying by 1/2. So that both patterns can be thought of as having a multiplicative pattern. Again, those strategies that students name for finding those patterns, we would record those on an anchor chart so that, again, students can refer back to those as they're working later on in the period. And then last, we would end class with an exit ticket, circling back to the article that we read at the beginning about the population in Vancouver. Part of the article also actually gives the population of Vancouver over the last 3 years. We would then look at those numbers and see if we can find a geometric sequence or a pattern that we could use to then predict the population in the year 2025. Students, again, could refer back to the anchor chart for strategies for finding that pattern so that, again, if they get stuck, they have an entry point. And then that would be an exit ticket that, as a teacher, I could use to assess where kids are, and I could use to plan for the next day.